Welcome to your lesson on right angle trigonometry. How much do you know about trigonometry already? There's an assumption in this lesson that you have studied basic trig ratios and have practiced lots of applied problems already. So we'll be moving through a lot of material in this presentation. Let's see how you do. So we're going to begin with a quick introduction and review of the basic trig ratios. We're going to look at angles of elevation and depression, bearing problems, and we'll finish with 3D problems. First of all, trigonometry is the study of how the sides and angles of a triangle are related to each other. The word trigonometry comes from the Greek words that mean triangle, measurement. Let's begin at the very beginning. We have these, in a right triangle, we have these two sides which are called the legs, and we have this side opposite the right angle called the hypotenuse. It's important to know what the sides are called in relation to an angle. If we're talking about angle M, we have a hypotenuse here because it's across from the right angle. But this side beside to the angle that we're dealing with is called the adjacent side. The side across from the angle we're dealing with is called the opposite side. So what is opposite, or what is this one called here? What is JK? Well, that's the adjacent side. How about KM? Opposite side. Which leg is opposite angle B? FH. Which leg is adjacent angle B? BH. Which leg is opposite angle F? BH. Which leg is adjacent angle F? FH. Okay, now that I have the words down, you're ready for the basic trig ratios. They are sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, opposite over adjacent. And we always say sine of an angle, cosine of an angle, tangent of an angle. Okay, these you have to know. An easy way to remember them is SOHCAHTOA. This is a common phrase used in all over the world to deal with trig. SOHCAHTOA sounds like soaking your toe. So meaning sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Alright, a big idea in trig. So grab your calculator, make sure you are in degree mode. To do that, you can press mode right here, and you'll find a setting in there you can change to degrees. Make sure you go degrees. And now, what do you get when you enter tangent of 27 degrees? You should have gotten 0.5 or 1/2. Let's take a look why. We have two triangles here. They both have an angle of 27 here. That means that all the other angles will be the same as well. So these are called similar triangles. In other words, one is just a bigger version of the other. In similar triangles, when you have a side length, it grows proportionally. Every side length does. So this side grew 2 times as big. That means this side, 6, also will grow 2 times as big, and this one also 2 times as big. That's what happens when you have triangles with the same angles. So tangent in here will be opposite over adjacent. That means 6 over 12. And that's 0.5. And that's what you got on your calculator. You did tangent of 27. But here we have a bigger triangle. So we're going to do tangent here also. Tangent of angle C is opposite 12 over 24. That's also 0.5. So the point here is that when your calculator gives you that value of 0.5, when you punch in a trig ratio, it's telling you the proportion between two sides of a triangle of any size that has that angle. Okay, so tangent of 27 will always be 0.5, no matter the size of the triangle. Okay, let's try some basic trig problems. Here we have this right triangle. We need to find out what y is. So let me show you this example. This one, we're looking at this. We're saying we know that angle. Here's our adjacent side. Here's our opposite side. Here's our hypotenuse. So opposite of 42 is y, and then we have our hypotenuse. We don't know adjacent, so we know we're going to set up a trig ratio which puts together the opposite and the hypotenuse. And that trig ratio is sine. Sine is opposite of our hypotenuse. So sine of angle 42 is y over 37. And then we can multiply by 37 here, and we have y. So y equals this value here. Next one, let's see. I see 63 here. I see the adjacent side is called x here. I see the opposite side is 20. We don't have the hypotenuse. So which trig ratio brings opposite and adjacent? That trig ratio of the 3 is tangent. Tangent is opposite over adjacent. So tangent of 63 degrees, opposite side over adjacent, 20 over x. If we want to solve for x, we can multiply by x here and then divide by tan 63 to get this. Solve that on your calculator, you get this length. Alright, in this one we see the angle is the unknown. We can still use trigonometry because we have two sides that are known. So we are going to use cosine because cosine brings the adjacent over the hypotenuse sides together. So cosine of this unknown angle is adjacent side over hypotenuse. And that works out to, well, there's another step we need to know in these ones. When we have the angle that is unknown, we do what's called an inverse trig function. So we do an inverse trig function on this ratio, and we will have the side length. And this is how we denote the inverse trig function. That works out to this. Make sure you know how to punch this in your calculator. You'll press second cosine to get this inverse, and then you'll get this angle. All right, try these two. Now check your work. And now try these two. And check your work on these. Okay, here's another one. So trig often is not so simple as just one triangle. There's often some kind of combination of triangles. Let's try this one. So you're going to find H, and then you're going to find angle A. Okay, so to find H, we're going to use a tan ratio in this triangle. And once we know H, we have enough information in this right triangle to set up a trig ratio as well. And we use tan again, this time doing an inverse tan to find that angle. The point is we always need two parts in a right triangle to be able to use trig. And in the beginning here, we only knew one portion or one side, but once we got that H, we knew two things about that triangle. All right, how about this one? We're looking for P and Q. With this one, it might be easier to start with, let's see. Yeah, start with Q first. And then that Q will allow you to solve for this one, which allows you to solve for P. Let's take a look at the work there. So if we do tangent in the entire triangle, we can find Q. Once we know Q, we can use this little triangle to find this length here that is not marked on here. Once you know that length, you can do 55 minus that length to get your P. Check out everything there. Alright, let's talk about angles of elevation and depression. An angle of elevation is an angle from the horizontal line raising up to look at some object like this. Alright, so always the key here is we begin at a horizontal. So imagine you're looking straight ahead, that's a horizontal line. Then you lift your head to look up, that creates the angle of elevation. Angle of depression is the opposite, looking down. So first, imagine you're looking straight ahead, horizontally, then you tilt your head down to look at something. That creates the angle of depression. A common mistake is students believe this angle right here is the angle of depression, but it is not. It has to be this one between the horizontal and the line connecting to there. Alright, so here's another diagram of that. Angle of elevation from the horizontal looking up, and angle of depression from the horizontal looking down. So what is the angle of elevation from B to D? That is 15. What is the angle of depression from D to B? That is not 75. If you said 75, that's the mistake I said people commonly make. First you need a horizontal, imagine you're looking straight ahead, and then this is the angle of depression. So that angle is 15. It is the same as this one because we have parallel horizontal lines. Okay, next. So here is a simple problem. Try this one. So that one had an angle of elevation idea in it, but simple trig can be used there to find the height of the tree. How about this one? Also a simple problem. Angle of elevation it's asking for, or no, it's finding length of the string, and it gives you the angle of elevation. So if you made this into a right triangle, you would have an angle of 60 here, and then you can use cosine to solve the length of the string. Okay, those are basic. Let's try another one here. This one's not so bad either, but the diagram might be a little strange. In this one, you should know also that this famous balcony, supposedly in Verona, Italy, we have that balcony where Romeo stood and looked up at Juliet. So there's a picture of that. But here's the work for this one. Let's say we have this diagram. Romeo here, 3 meters from the building. I know the balcony you would think is sticking out of the building, but there's an assumption that the balcony is lined up with the wall of the building. So he's 3 meters away, she's standing there, and then they have the same height. So I marked this height here as his height, but she has the same height, so I marked that H also. I call them both H. We have this right triangle kind of happening here. and there's an angle of 70 degrees here. He looks up, and if we use that right triangle, we can find the length of x plus h, which is this little bit plus her height. Okay, so we can do tangent of 70 is x plus h over 3, basic tan ratio. That allows us to solve for x plus h. So x plus h, oh, I wrote that twice, that's strange. Funny. Okay, there's x plus h, it's 8.24. So this entire length is 8.24, but the question was asking about the height of the balcony. Well, the nice thing is, since their heights are the same, that this x plus h is the same as here, this x plus h, because his height is the same as hers. So we've already found x plus h, which is the height of the balcony right here. Here's the next problem. Read this and try it out. And now check your work here. Pause it if you need to. Main thing is there's two triangles created, one with the elevation, one with the depression, and then you combine those two lengths to get the full height. Okay, how about this one? Let's check our work here. Again, we're using multiple triangles. Here's one triangle. We can make a big triangle. That triangle allows us to solve this length right here. Then we have another triangle here with an angle of 72 when you combine those, and it allows us to solve the length BC, which is this short length here. Once you have those two lengths, you can subtract to get the length that you need, which is the length from person to person here. Take a close look. Pause if you need to. All right, maybe you've been on a ship at some point and somebody has said, Captain, we are at a bearing of 52 degrees. What does this mean? What is bearing? Let's talk about that for a moment. A bearing is basically a direction of movement. A bearing is always given from north. So if somebody said we are a bearing of 40 degrees, that means 40 degrees spinning from north, like this. It can also be written north 40 east. So bearing north 40 east, or just 0, 40, like that. We use a 0 here because eventually the angles will be in the hundreds. Okay, next one. Let's say, what would be your bearing for this one? Well, one way to write that is bearing west 20 south. You go west and then 20 degrees in the south direction. Or, more commonly, you'll see it like this. 250 degrees. Again, we begin at north and we start spinning. 90 degrees, 180, 270 will bring us to here, but we're 20 degrees short of 270, so we're 250. So remember, bearings always start at north. All right, you can also say south 70 west. All right, you go south and then 70 degrees to the west. So it's kind of unlimited how many of these you can use here, but this is the main way you should know right here. Let's try this problem. Okay, what do you think? So first of all, you have to decide. Somebody's starting at a starting point. It can just be a point, and then they are running for 5 kilometers, but you need to know their direction. And it says the direction is a bearing of 120 degrees. So remember, start at north, spin 120 degrees, and that will bring you to the direction of their travel. So it should look like this. We are starting at north, I spin 120 degrees, so that's beyond 90, 30 more here. And that is the direction of their travel. This is the starting point right here. So now we know their direction, and we know that they run 5 kilometers in that direction. So we can show 5 kilometers like that. And then you can draw a line straight up, because the question is asking how far south. So if somebody's running at this angle here from east, then that is the distance south they have traveled right here. We have this simple right triangle. We can use sine, and we can solve for that distance going south. Let's try another bearing problem. Okay, so let's see. We have a lighthouse and a boat due south of it, and we're trying to figure out how far the boat is from the lighthouse after it's moved a little bit. Anyway, boat begins due south, so I'm going to go like that, just show north and south. And then we know the boat is moving on a bearing of 292. So the direction of travel of this boat is a bearing of 292. So how do we get the bearing of this boat? Which direction is it going? This way, this way, this way. Which way is it sailing or moving? So again, we start at north, which is in the direction of the lighthouse, and we go 90 degrees to here. So I can put that here. So 90 degrees to here, 180 to here, 270 to here, and then we need an extra 22. So the direction is like this. Again, 90, 180, 270, 22 degrees more to make 292. It travels 51 kilometers in that direction, and here that gives us an angle of 68 because these make 90. So it goes 51 kilometers and ends up being at a spot that is directly due west, it says. So now we have this right triangle, and we can solve for the distance from the lighthouse where the boat will be. Great problem. All right, nice work with trigonometry. We'll see you soon.